Today we will discuss fluid dynamic chapter. But first of all, we will start from fluid. That what is fluid? Fluid is basically everything that flows, like liquid and like gas. Both liquid and gases are fluids because they flow. Now we will study about flow of fluids. Flow of fluids is divided into two parts. The first is hydrostatic, when the fluid is at rest. In the second is fluid dynamics. Fluid dynamics, that is our chapter name. It is the study of fluid that is in motion. Now liquid and gases, both are fluids and that can flow. So the study of gases when flow and the study of liquid when flow is called fluid dynamics. Both have got a special name. So when a liquid is in motion, we call it hydrodynamic. And when gas is in motion, we call it aerodynamic. Whenever there is flow of fluid, they have some sort of resistance, and the resistance to flow is shown by coefficient of viscosity, that is represented by eta. Eta represent MCQs number first. Anyone can ask you, or even it may come in eta, that eta represent coefficient of viscosity, or V number, velocity, or C number, resistance, or D none. So option A is right. Now we will discuss viscous drag or drag force. The drag force is represented by Fd. An object moving through a fluid experiences a retarding force called the drag force. Whenever a fluid, this is tube in which fluid is moving, when an object moving through this fluid, this is an object, when object is moving through fluid, it will face a retarding force that is called the drag force. A small example is whenever we put our hand outside a moving car, we will face a force acting on our hand, and that force is called Fd, drag force, because our hand is acting as an object and the air moving is in fluid. So the hand when moving in a flow of air faces a force that is called viscous drag or drag force, represented by Fd, and that force is directly proportional to speed of the object. So when the car is moving slowly, the drag force will be minimum, and if the car is moving too fast, the drag force will increase. So the Fd is directly proportional to velocity of an object. Here we would like to define the Stokes law. There is a law called Stokes law, that is between the drag force and velocity. So Stokes laws tell us that Fd is directly proportional to coefficient of viscosity, the radius of an object, radius of a spherical object, remember spherical, and velocity of the spherical object by putting the constant k, that equal to k eta rv, fd is equal to k eta rv, where k is equal to 6 pi. So the equation become fd is equal to 6 pi eta rv. From the equation it is clear that fd is directly proportional to velocity, but when the velocity is slow or low. At high speed, remember this per eta, at high speed the fd is directly proportional to square of the velocity. So all the MCQs that arise from Stokes law, we will discuss it one by one. So the MCQs on Stokes law are here as follows. MCQs number second is fd is equal to 6 pi eta rv is fd 6 pi eta rv is Stokes law, Newton's law, Courier law, none of these. So we know that fd is equal to 6 pi eta is Stokes law. MCQs number third, constant k of Stokes law equal to pi, 2 pi, 3 pi, 6 pi. From Stokes law we know that fd is equal to eta rv. We put constant here k eta rv, where k equal to 6 pi eta, and the equation become fd is equal to 6 pi eta rv. So it's the solution. So answer 6 pi is right answer. MCQs number 4, Stokes law is valid for, Stokes law is for, or Stokes law is valid for spherical objects, regular objects, irregular objects, all of these. Stokes law is valid only for spherical objects. Remember that Stokes law is valid for only spherical objects, not for regular or irregular, all of these are any other option. MCQs number 5, air drops falling slowly, so choose the correct relation between for fd and velocity. So here remember this term slowly, airdrop is falling slowly, so we know from Stokes law the fd is directly proportional to velocity. If they replace MCQs number 7, but if they give that airdrop falling at high speed, choose the correct relation, then that in that case the correct answer will be option C, fd directly proportional to v2 square. So must remember that fd is directly proportional to velocity at slow speed, and fd is directly proportional to velocity square at high speed. MCQs number 6, spherical object, spherical drop falling at slow speed has drag force of 10 Newton. So it's falling and fd is 10 Newton. Find its force if it falls at high speed like 4 times of initial value. So the solution will be like this. I want to get place for the solution, so I will remove MCQs number 2 and 5 and also this point. We know that fd in given case is 10 Newton, which is at low speed, and they gives that points its fd, we have to find fd dash if its high speed is 4 times of initial value, if its v2 is 4 times of vi. So we know that fd is equal to 6 pi eta rv, fd is directly proportional to eta rv, v is increased 4 times, so it will becomes 6 pi eta r v, 4v. So the 4 will comes forward, but we know that we must remember that we will put here square, because this value is given at slow speed, but we have asked to find f for high speed. So at a high speed fd is equal to 6 pi eta r v square. So by putting V2 is equal to 4 Vi. We will get that 6 pi eta r 4 Vk square. So we will get 4 4s are 16 and 6 pi eta r V square, that is Fd. 16 times the force will increase. So 16 multiplied by where Fd was 10 Newton, that is 160 Newton. So the answer is 160 Newton. B number 60 Newton, or C both of these, or D none of these. So the option 160 is right answer. Now we will start terminal velocity Vt, that is terminal velocity. Terminal velocity. Terminal velocity is constant falling velocity. Suppose this is cloud, a water drop starts at initially it is 0 velocity. A water drop start falling downward at certain speed, at certain time it will get its Vfm, final velocity, maximum final velocity, maximum final velocity constant. So whenever a water drop starts falling from a cloud, after some time it will get its maximum velocity. It will not increase further its velocity. So it will start falling with constant maximum velocity. This constant maximum velocity is called terminal velocity. Now we will get 2 to 3 position for air drop. This is the first position in the cloud, that is point A. In the last position, that is called point C, and we will take another point at the middle called point B. This is a drop falling started from point A and reached to the earth, but we will get 3 position point A, B, C. At point A, when it is not started falling, the net force acting on it is the downward force, that is W. So the net force acting at point A is W. At point 2, so the drag force will act on the drop in upward direction, that is Ft, but the drop will try to fall downward due to weight of the drop. So two forces acting on a drop at point B. So at point B we know that the drop is falling downward, so it shows that W is higher than Fd. So the net force F net equal to W minus Fd. At certain point where its velocity increase, Fd will also increase. At point C, velocity will get its maximum value, so Fd will also get maximum value. So the Fd will be equal to F weight of the drop, so it will become 0. F net at point C, this is for point B. So at point C, F net is equal to W minus Fd. At C, W is equal to Fd, so it equal to 0. So the net force acting on a body is acting on a drop at point C is 0. So it drop at constant velocity, and that constant velocity we call it terminal velocity. Now we will draw, or we will find the equation for terminal velocity. We know that Fd equal to 6 pi eta Rv. So and we also know that W is equal to mg. At point C, when we get terminal velocity, at that point weight equal to the drag force. So both cancel the effect of each other, and we in the Drop falls at constant terminal velocity. This is the drop. Weight x downward, drag force x upward, at terminal velocity both equal. So we know that W is equal to mg, Fd is equal to 6 pi eta or Vt. So the Vt becomes mg divided by 6 pi eta r. Also we know that density equal to mass per unit volume. Density equal to mass per unit volume. So mass will be equal to rho v. Mass equal to rho v, and volume of the drop that equal to 4 by 3 pi r cube. So m equal to rho 4 by 3 phi r cube. So putting this in the equation, we will get Vt is equal to rho 4 by 3 pi r cube g 6 pi eta r. 1 r cancel with the cube, it will become the square. Pi cancel with pi, we will get 4 rho gr square and 3 6 are 18 eta. 18 eta. Cancelling 4 and 2, we will get 2 9. So the equation is 2 rho gr square divided by 9 eta. This is the equation for terminal velocity. So at last the terminal velocity equation is 2 rho gr square divided by 9 eta. Must remember this equation. And now we will solve the equation on terminal velocity equation. Here is MCQs on terminal velocity. MCQs number 8 is choose the correct equation for terminal velocity. Equation number 1, Vt is equal to 2 rho gr cube divided by 9 eta. It's wrong because here is no 9 and this is square. MCQ option 2, rho gr square divided by 9 eta. So here 2 is missing. Option C, 9 rho gr square divided by 2 eta, and option D, 2 rho gr square divided by 9 eta. Option D is correct because it is 2 rho gr square divided by 9 eta, not 9 rho gr square divided by 2 eta. So must remember the correct equation for terminal velocity. MCQs number 9, if we double the radius of the drop, its Vt becomes double, half, quadruples, or none of these. So we know that Vt equal to 2 rho gr square divided by 9 eta. Putting r here, 2r. So 2 rho g 2 arc square divided by 9 eta. So square is on 2 and that is on r2. So 2 2s are 4 and we will write 2 on the front. So 4 2 rho gr square divided by 9 eta. This is our Vt. So 4 Vt. So the option C is correct. If we double the radius of the plot, its Vt becomes 4 times. Option C is right. Now MCQ 10 is the radius of a drop are reduced to 1/4. Its Vt remains same. Quadruples reduces by 1/4. So we know that Vt is equal to 2 rho gr square divided by 9 eta. 2 rho g, the r is decreased by 1/4, or the r is reduced to half. So r by 2 square divided by 9 eta. So 2 rho g r square by 4 9 eta. So writing in on the front, 2 rho gr square divided by 9 eta 1 by 4. So the option C is correct. Whenever we reduce the radius to half, the terminal velocity reduced by 1/4. MCQs number 11 is, if the R is reduced by 1/4, then the VT, option A, reduced by 1/4, reduced by 1/16, increased by 4 times, or none of these. So the solution is, by terminal velocity equation we know that Vt is equal to 2 rho gr square divided by 9 eta. Again 2 rho gr square divided by 9 eta when the radius is reduced to 1/4. Now further solving it, 2 rho g r square divided by 16, 9 eta. So 2 rho g r square divided by 9 eta, writing at the front, it will become 1/16. So the option B is correct. Whenever the R is reduced by 1/4, the terminal velocity will be decreased by 1/16. MCQs number 12 is, that is so tricky and may become in ETA 2020. Find the ratio of a terminal velocity. We have to find the ratio of terminal velocity of a drop falling. Now we have MCQs number 12, that is find the ratio of terminal velocity, that is Vt, for a drop for falling on Earth to that on moon surface. So option A, 1/1, 6/1, 1/6 and 6/8. So we know that Vt is equal to 2 rho gr square divided by 9 eta. For moon g will be gm, and for earth terminal velocity will be 2 rho gr square, that for earth divided by 9 eta. Now we know that g on moon is equal to gr earth divided by 6. So here we have to find ratio of earth to that of moon. So we know that Vt is equal to 2 rho, and putting for that Ge we have G is equal to 6 times G of moon. So 2 rho 6 times of Gm r square divided by 9 eta, that is Vt per earth. So we will get that Vte is equal to 6 into 2 rho gm 2 rho g r square divided by 9 eta, and that is 6 into Vt of moon. So we will get that Vte is equal to 6 times of terminal velocity that on moon. So Vte divided by Vtm is equal to 6, that is equal to 6 divided by 1, that's also is equal to 6/1. So the answer is 6/1. Now we have MCQs number 13. If a drop A has double the radius of drop B, then the ratio of terminal velocity of A to that of terminal velocity of B is 2/1, 1/2, 4/1, 1/4. So we know that by terminal velocity 2 rho gr square divided by 9 eta. For particle A, we will, for drop A we will put radius of A, B, A, and for B we will put the radius of B. No, from the question it is given that the ratio of A is, radius of A is double of radius of B. So we can also write this equation as 2 rho 2 times of RB square divided by 9 eta, or 2 to the power 2 is equal to 4 is equal to 2 rho gr square divided by 9 eta. Now to find is Vta divided by Vtb. So this whole thing, that is 4 2 rho gr square or b square divided by 9 eta divided by Vtb, that is 2 rho g rb square divided by 9 eta. So this cancel with this and we will get simply 4 or 4 divided by 1 or 4 ratio 1. So the answer is 4 ratio 1. The next topic with us is equation of continuity. So be in mind that equation of continuity is based on law of conservation of mass. It means that mass is neither created nor destroyed. Equation of continuity, that is, if the product of AV remains constant. Now to prove this, we have a 5 in which fluid is moving. We have 2 points, that is A, another point, that is B, of radius R A, R B, area A, area A. So at point A and point B, the mass point A is equal to the mass at point B. Now we also know that density is equal to mass per unit volume. So we will get M is equal to rho V. So delta M is equal to rho delta V is equal to rho delta V for A and B. R, this is R1, A1, R2, A2, point 1 and point 2. So we can also write this 1, 2, 1, 2. So from volume, if we have 5, this is 5, this is the area and this is the distance. So multiplying A multiplied by S, we can get the volume. So we can put here V is equal to A multiplied by S, A1 multiplied by S, and here we will get A2 multiplied by S. Now from equation V is equal to S divided by T, we can get that S is equal to Vt. So here putting V multiplied by T, A1, A2, V2, S. So cancelling rho with rho, because the fluid is ideal, that means that it is incompressible. So here we will get A1 V1 is equal to A2 V2, or A1 divided by A2 is equal to V1 divided by V2, or the product of AV is equal to constant. Next, this is the equation to be in mind. Next, another MCQ that is also help us. We know that density is equal to mass per unit volume. So rate of change of density is rho delta V by T. So the next is, this is the equation for rate of mass. Another equation that is called rate of volume, that is also important. So again here we will derive the equation for delta V by T. Delta V by T, this is the equation for delta M by T. This is A1 V1 divided by A2 and V2. So we know that from this rho V1 is equal to rho and V2. So putting here V1 is equal to A multiplied by S, here S is equal to V and T, that is equal to rho V2, rho V2. So density cancel with density, we will get AVT is equal to volume. So we can also write AV divided by V divided by T. So for the rate of change of volume, we will get that rate of change of volume with respect to time is equal to the product of A and V, that is the equation of continuity. So we can also write that the product of AV is equal to delta V by is equal to delta T. So it can come in MCQs, that MCQs number 14, choose the correct For equation of continuity, at AV is equal to constant, delta V by delta T is equal to constant, or A1 divided by A2 is equal to V1 divided by V2 is equal to constant. So all of these are correct. Now for MCQs, these three equation number 1, equation number 2 and equation number 3 are most important. Now we will solve MCQs on equation of continuity. Now we have MCQs on equation of continuity. MCQs number 15 is for the velocity at point A, this is point A, and point B, which one is current? Which one is correct? So answer is velocity of A is greater than velocity of B, velocity of A is smaller than velocity of B, velocity of A is equal to velocity of B, and velocity of A is double of velocity of B. So we know that from the equation of continuity that velocity is inversely proportional to area. So as the water comes downward from the tap, the area decreases. As the area decreases, so velocity increases. So at point A the velocity is greater than point B. So option A is correct. Number 16, continuity equation is based on law of conservation of mass, energy, both of these, none of these. So equation of continuity is based on law of conservation of mass, while Bernoulli equation is based on law of conservation of energy. The next one is MCQs number 17. Velocity of water in 6-inch radius is 5 feet per second. Find the velocity in 3-inch radius pipe. So the given information is, we have no need to diagram, but for your concept I will write it. 6-inch radius, the velocity is 5 feet per second. Now if the radius is decreased to what? 3-inch radius, find the velocity or V2. So we know that from continuity equation A1 V1 is equal to A2 V2, but instead of area they have given us the radius. So for pipe we have area is equal to pi r square. So the equation becomes pi r 1 square V1 is equal to pi r2 square V2. Pi cancel with cancel, we will get r1 square V1 is equal to r2 square V2. So for to point V2 we will get r1 square V1 divided by r2 square. Here r1 is 6-inch, velocity at V1 is 5 feet per second, and radius 2 is 3. So we will get 36 multiplied by 15 divided by 9. 9 4s are 36, 4 5s are 20 feet per second. So option C is correct. Now MCQ number 18. If they give MCQ number 18, instead of radius they give us diameter. So if they give dia, then what will happen? So if they give us diameter instead of radius, so we will use the same equation, that is A1 V1 divided by 3 dia. A1 V1 is equal to A2 V2. From area we know that pi r1 square is equal to V1 is equal to pi r2 square and V2. Now we know that radius is equal to pi cancel with pi. We know that radius is equal to diameter by 2. So we will get diameter of 1 square V1 is equal to diameter of 2 to the divided by 2 whole square V2, or d1 square V1 divided by 4 is equal to d2 square V2 divided by 4. 4 cancel with 4. So we get the equation that relates diameter and velocity. So to find v2, here we will get d1 square v1 divided by d2 square. So d1 is 5 square multiply diameter is 6, so 6 meter square divided by 3 square, so 9 4s are 30. So again we will get 20 feet per second. So you must remember that a1 v1 is equal to a2 v2, also pi r square, so r1 square v1 is equal to r2 square v2. If they have given diameter, so d1 square v1 is equal to dt square divided by multiply by v2. So these three equations must be in mind to solving the continuity equations. Now we will solve MCQs number 19. Here are two more. Now here are two more MCQs with us for equation of continuity number 19 in 2019. State that for given pipe, a point B is double radius of point A. Find the velocity A of B ratio A. We have to find velocity of B to that of velocity of A. V divided by V A. But the given information is just ratio of point B is double of point A. For a given pipe, a radius of point B is double of point A. So we know that A1 V1 equal to A2 V2 by putting area is equal to pi R1 square, V1 is equal to pi R2 square V2. Pi cancel with pi. In the question they have given that if radius at point P is double of A, matlab it means that if we have RB and RA, according to question we have RB is 2 times that of RA. So we can also write that R1 square V1 is equal to, as R2 is 2 times R1, so we will write 2 times R1 square V2. Now to find velocity of B to V1, to find as V2 divided by V1. So we will get R1 square divided by 2 square equal to 4, and R1 square is equal to V2 divided by V1. So R1 cancel with the, and we will get answer is 1 ratio 1 divided by 4, that is 1 ratio 4. Now MCQs number 20 states that for given pipe AB point, if RB is double of radius at point A, it means that this is RB, this is RA, and RB is double of RA. Then the velocity at point B is, so then the velocity at point P is, writing option 2 pi meter per second, 10 meter per second, 20 meter per second, 40 meter per second. So we know that A1 V1 equal to A2 V2, A1 is equal to pi R1 square, V1 is equal to pi R2 square V2. Pi cancel with pi. So R2 is double of R1, so we will write 2 R1 square instead of R2, that is equal to 4 into R1 square. So R1 square V1 is equal to R2 square V2. We can also write R1 square V1 is equal to 4 R1 square V2. R1 square cancel with R1, and the velocity at point A is 10 meter per second. The velocity at point A is 10 meter per second. So 10 meter per second is equal to 4 into V2. So 10 divided by 4 is equal to V2. 4 2s are 8, and 25, 2.5 is equal to V2. So little bit in change in option. So the option may be 2.5 meter per second, 5 meter per second, half of 10. Now 10 meter per second or double of 20 meter per second. Take the screenshot of the MCQs for it may help you in next time. MCQs number 20. MCQs number 21. Choose the correct for given water pipe. This is given water pipe where RA is radius at point A and VA is the velocity at point A. RB and BB are radius and velocity at point B. RC and VC are radius and velocity at point C, and so on. And they have asked for the relation between velocity at point A, B, C, D and E. So from the continuity equation we know that area is inversely proportional to velocity, or area is equal to pi r square is inversely proportional to velocity, or radius square is equal to inversely proportional to velocity or radius. So from the equation it is clear that radius is inversely proportional to velocity. So first we will write the equation for radius. So we know that RE is smaller than RB and RE is smaller than RB and that is smaller than RA, and further RA is smaller than RC and RC is smaller than RD. So from the continuity equation, as the radius is inversely proportional to velocity, so velocity at point A will be greater than velocity at point T, will be greater than velocity at point B and velocity at point C, and so on. So to find the correct option is VE is greater than VB, VE is greater than VB, VB is greater than VA, and VA is greater than VB is greater than. So this is a EBACD, EBACD. So option C is correct. This is simple equation by conceptual question. It may help you in MDCAT, ECAT in Aga Khan Medical College entry test. So must remember that radius is square is also inversely proportional to the velocity, as area is formed from area equal to pi arc square. Now let's derive an equation of Bernoulli equation in short or few steps. Now and then we will solve MCQs on Bernoulli equation. Bernoulli equation. Now Bernoulli equation is the relationship between the pressure, flow speed and height of flow of the ideal fluid, and this relationship is called Bernoulli equation. So if we have 2 points for a moving fluid in 5, that is point A and B, now the relation at point pressure, velocity and height at point E to that of pressure, velocity and height to point B, we will use Bernoulli equation. Now to prove Bernoulli equation, we must remember that Bernoulli equation is law of conservation of energy. Now according to law of conservation of energy, energy can neither be created nor destroyed, but it can change from one form to another form. For point A, there is total energy, or we call it W. If this fluid comes from A to B, it will get some sort of energy that may be in the form of kinetic energy or potential energy or both of these. So for point A, the total energy that appears as work done is equal to kinetic energy plus potential energy. So we know that W equal to FD. Now by pressure equal to force per unit area, we can also write that force is equal to pressure into area. So we can write PAD. Now if D is the distance and this is the area, Now A multiplied by T give us the volume. So we will get P into V. Now further we know that density equal to mass per unit volume. So volume is equal to mass divided by rho. So we can write pressure is equal to mass divided by rho R. R change in pressure it is equal to m divided by rho. Now for change in work done will be equal to change in kinetic energy plus change in potential energy. Now change in kinetic energy is equal to K2 minus K1 jama potential energy is equal to P2 minus P1. K2 is equal to half mv2 square minus half mv1 square jama mgh2 minus mgh1. This is h2, this is h1. Now further we can also write that half, taking half m constant, v2 square minus v1 plus taking m constant we can get gh2 minus gh1. So we can also write that half m v2 square minus v1 square plus m gh2 minus gh1. M can taking m from these both equation constant we can write that. So cancelling m with m we can get delta P divided by rho. So multiplying rho to this side we will get delta P is equal to, now multiplying rho to both of these we will get half rho v2 square minus v1 square jama rho gh2 minus rho g h1. So we can also write that p2 minus p1 is equal to half rho v2 square minus half rho v1 square, multiplying half rho to each of these into rho gh2 minus rho g h1. Now taking 1.1 and 0.2 to both on their side, P2 minus half P2 minus half rho V2 square minus rho GH2 equal to minus half rho V1 square minus rho GH1 plus P1. R. Now there is little mistake. The delta P is P1 minus P2. So this is, see, this will be minus P2. This will be minus P1. So taking minus minus from both sides, or taking these terms on the right and these on the left, we can get that half rho V1 square plus half rho G1 plus P1 is equal to P2 plus half rho P2 square plus rho GH2. This is the equation of Bernoulli equation. Now in Bernoulli equation, P plus half rho V plus rho GH is equal to constant. As these three on same side and same line, same numerator, so we can write that pressure is inversely proportional to velocity, or velocity is inversely proportional to, and pressure is inversely proportional to height. So must remember that pressure is inversely proportional to velocity. Greater the velocity, lesser will be the pressure, and so on. Now let's solve 5 to 10 MCQs on these. There are 2 MCQs on Bernoulli equation. The first one is 22 number is related with torsion theorem, and 23 is in aerofoil wing. So the 22 number is for a given 2 holes in the given tank, which one is correct? VA divided by VB is under root 10 divided by under root pi, or VA divided by VB is under root pi divided by 10. So this, for to find the velocity, we use torsion this theorem. This is based up, that is based up Bernoulli equation. But simply, if velocity, this is the water and tank. If we have tank, this is the height of from top of water to hole. So to find the velocity at this point, we use torsion theorem. So in going to that long derivation, we will consider is that suppose of water, this is falling at a stone to from height that of h, and to find the velocity at this point, both velocities are same. So we know that initial velocity of water is Vi, final velocity is Vf. Now we know that 2as is equal to Vf square minus Vi square. Now the initial velocity is considered as 0 because the it starts falling from 0 velocity, so it will be 0. So we can write that 2a, write g instead of a and h instead of s. We will get 2gh is equal to Vf square. Now to cancel the root, we will write 2gh is equal to Vf square or V square. So this is the equation of torsion theorem, or to find the velocity of water. So here the height is, we will count the height from top. So here the height is 5 meter, and to the whole B the height is 10 meters. So for B or for A divided by V, VA divided by VB is equal to under root 2G HA divided by under root 2G HB. 2G root cancel with the, we will get HA divided by HB. So the option, we will make little changes in the option. That will be option A is equal to 10 and 5. 10 divided by 5 is equal to 2. 5 divided by 10 is equal to 0.5. So here HA is 5 meter and the HB is 10 meter. So 5 divided by 10 is equal to 0.5. So option B is correct. If they give an answer instead of 2 and 0.5, like 2:1 or 1:2, so this will be the correct answer. Now next on, for an aerofoil wing, the velocity below wing is greater, less or same as velocity above the wing. So if we look into the wing for in aeroplane, if we have suppose this is an airplane and this is the wing, so remember that the wing is in given in angle theta, not the wing is plane. So we give the angle is the wing in angle like that. So whenever the air comes and hit the wing, it moves upward. Like we can also draw that if this is the wing, and air comes and just pass as so. So the velocity at upper surface or velocity at A is greater than velocity of B, that is below the wing. So the velocity below the wing is lower than velocity above. So for an aerofoil wing, the velocity below wing is same, less or more. The velocity is less than above velocity. Is velocity below or VB is greater than velocity A. Velocity at A is greater than velocity at B. Now from Bernoulli equation, here the MCQs option is completed, but next I would like to some tips. As V is greater than V, so by Bernoulli equation, is velocity inversely proportional to pressure, so PA will be less than PB. So PB is below, so below pressure is more and upward pressure is low. As below pressure is more than upward pressure, so in this process upward force is produced in an aerofoil fluid. MCQ number 25. If air is blown between two balls, the ball will come close to each other, further away from each other, remains on same position, and none of these. These are two balls tied with a string, and a man blew air between two balls. So what will happen? So if air is blown, so the velocity at point B or in between of the ball will increase as compared to velocity at this point or this point. When air is blown, the velocity of B will be greater than velocity of A, and by Bernoulli equation, is the velocity of B is greater than A, the pressure at point B will be less than pressure A. Is pressure B is VB is greater than VA, then by Bernoulli equation, as both are inversely proportional to each other, so PA will be more than PB. As PA is more than PB, so the pressure at point A is greater than B, so the ball, there will be force appear from left to side of the ball, so the ball will attract each other. Same as in the case of MCQ number 27. If two boats are moving in same direction in the river, what will happen? They will come close to each other, attract each other, they will further away from each other, or remain the same. If two boats are moving in the river, what will happen? So if boats are moving, the velocity in between them or velocity at point B is also moving with the boat. So velocity at point B, and this is point A. So velocity at point B will be making more than velocity at point A. By pressure at point B will be less than point A due to Bernoulli equation. So as pressure is more from P to A, so it will attract each other. MCQ number 26. If air is blown over a paper lying on a table, then what will happen? Then paper will move upward, paper will move forward, or paper will move downward, or none of these. So to solve these MCQs, again this is based up, although it doesn't appear, but this is based on Bernoulli equation. The question says that if this is the paper lying on the paper, and if air is blown from side by someone, so if air is blown from over the page, so the velocity above will be more as velocity below the page. So as the air is stationary or below there is no air, and above velocity is moving with velocity VB, so we know that VB will be greater than VA. Below air is stationary or no air present, and above air is moving, so VB will be greater than VA, and pressure at point P will be less than PA. So an upward forces will act on the page, and the page will move upward. So the paper will move upward if air is blown, if air is blown above the paper. Now MCQ number 28 is, if you are standing on side of train and the train is moving, train or truck is moving, and you are standing beside the train, then what will happen? You will move towards train, or you will move away from train, or you will remain on same position, or what will happen? So whenever the answer is, whenever the train is moving, it also moves air with itself, or the air around the train is also moving due to the motion of the train. So the velocity near the train or velocity at point A near the train is greater than velocity of air at the back of U. As velocity is greater, A is greater than velocity of B, so P at point A is less than point B. Change in pressure occurs, so you will feel a force from backward, so you will go towards the train. So this was MCQ number 28.